All right, well, good afternoon, everybody. Welcome to your last virtual meeting for 141 Lab this semester. In some ways, this semester probably has dragged on for you and for me. Parts of this semester have been tedious and hard to get through with just the difficulties of communicating some of these complex topics. The troubleshooting has been particularly difficult. Not that I haven't enjoyed working with you, it's just the fact that I can't be there with you. Having that just in-person conversation has been rough, but we're here, we've made it, and we kind of have one last big project here to take care of before we move on to bigger and hopefully better things for the summer and for next semester. Just a quick recap. I'm going to spend just a couple minutes going over some of the rules and expectations that are included in the lab and the lab report. But in just a couple minutes, mainly it's you guys are going to be running the meeting, in the sense that I'd like to know what your ideas are, what you've tried so far, and even if you do have some preliminary results, share those with us. It'd be nice to hear from you about what went right, what went wrong, and if you have any preliminary results in terms of value for G or its error, its uncertainty, share that with us. In fact, if you remember, that is part of the points that you get for this lab. Part of the points that you get for this lab is not only for how close you get to G, as we'll review in a second, but you also get some points simply for consulting with me. That can take place right now in a discussion we have in front of the rest of the students, or it could take place via email or messaging, or even in our own Hangouts session later, depending on your schedule and where you're at with the lab. Again, I've tried to be pretty flexible in the sense not sticking with hard due dates. And so I realize you've got a lot of other things going on. So some of you may be at different places and different points in your with your lab and your experiment. I'm attempting now to switch back over to the Word document here. So just give me a second. Seems to be working now. Well, I'm not sure why I'm being asked to put in a product here. So hopefully this is something that will go away, and it doesn't look like it is. I can still go over the main points here, even if this doesn't work. I promise you, I do have a licensed copy of Microsoft Word. I'm not sure why this is a thing now all of a sudden. I may have to bail on this, however. So give me just one moment here. Okay, hopefully you can see me again there. I'm not sure what happened there. I was attempting to show you the lab report, but you guys can all download that. Essentially, I wanted to just highlight three things on there. Number one, we do need a full and complete description of your experiment there, including pictures or drawings. And so please be sure to include all of that to get full points. The second thing is that once you write your results in that appendix page 8 format, report those results, and then think about them for a little bit and consult with me in terms of what you're thinking. How can you improve on that experiment for sort of the second experiment? You know, what is your level of uncertainty? What is your fractional error? Is there a lot of randomness in your data? All of those questions kind of ask the same thing. If so, if that fractional error is greater than 5%, what can you do to improve that? Is there something we can do? Maybe you were just using a stopwatch, for example, and maybe we should switch over to a video type data gathering process. That's one possibility. Or what if you have a lot of systematic error in your experiment? What if your value for G is significantly off from 9.81? Again, systematic error would be indicated there. That is typically indicated by a high Z-score. So in that case, what's causing you not to get 9.8 or whatever your expected value is that you decided? Maybe it's the choice of object. Maybe it's dropping it from a shorter distance could help. Maybe the shape or the mass of the object, its mass in proportion to its surface area, is an issue. Finally, then you repeat and choose the best of your results to get that score as we described last week. So aside from my technical difficulties where I could not actually show you the report, that's the main points I did want to cover. So I've heard from a couple of you already. I've heard from one person that's not with us here right now, actually in this video call, but I've heard from one of you. So we don't have to raise hands necessarily, but if anybody would like to volunteer and just give us our thoughts, you can go ahead and turn on your mic and or your camera, at least your mic. If you don't want to show your face, that's fine. I'll hang back here, and I just want to know kind of what your thoughts are. What did you decide to do for your experiment for measuring G? And if you already have some results, feel free to share those with us. I'll turn it over to you. Anybody have any ideas they'd like to share? What they're thinking, even if you haven't done it yet, you can go ahead and just share with us what you're thinking. Perhaps we can give you some ideas or pointers or suggestions as well. Anybody would like to volunteer to let us know what their experiment is looking like? That would be wonderful. It's hard to go first, I know.
Excuse me, Priya. I think I'd go. So, for my first experiment, what I did was I took like a ball. So I threw it from a height of 0.5 meters. Then I did it 0.5 meters. Then I did it at a 1 meter, 1.5, and then after that I I calculate the value for, like, I drew a graph between the time and the time squared and the distance, and I got a rough estimate of the G. So how would you think, like, for my next experiment, what suggestions would you say me to improve the value of G? I use like a small ball, like a table tennis ball.
Okay. Yeah, so a couple things there. Let's just go over the basics of your experiment. You dropped an identical object from varying heights. So what's interesting about your approach is for the other experiments that we've done and the way that typically kinematics and moving objects are graphed in physics, typically time goes on the x-axis. And you and I had this conversation before. But because you chose the different displacements, essentially, you chose different delta x's or delta y's in this case, time actually is going to be your independent variable, or excuse me, the displacement is going to be your independent variable. The time is going to be your dependent variable. So he's actually going to put time and time squared, as the equation would indicate, on the y-axis. So that it might seem strange because we've never really viewed a graph in that sense, in that way in this class, but just because of the design of your experiment, you've done that. And so do you have a value for G and an uncertainty and a z-score calculated yet?
So the value of G is the slope, right, Professor? Twice the slope.
Yeah, if I remember correctly, it was was it twice the slope, or is the slope over 2? I don't. I'm not sure I can do that in my head. I have to write down the equation again.
Let's see.
figured I'd be doing some scribbling here off to the side.
So yeah, Professor. So I got around 9.82357.
Okay, and then what was the uncertainty, that standard error that in the regression? What did that come out to be?
The Z score value, like the actual value minus expected divided the score.
Yeah, you could give me the z-score as well.
Yeah. Z score. Let's see. Um, mm, Professor, I've not calculated the Z score, Professor.
Oh, that's okay.
Yeah. That's all
quite
I've
all
done
right.
till now. I
Okay.
graphed the equation. I just multiplied it right now.
Okay.
Yeah. And my G value was whatever I just told you.
So the theory here, I can scribble this down, is that we started out with one of the well-known kinematic equations, and we just we rearranged it such that when we graph t squared on the y-axis and displacement on the x-axis, as you can see there, the slope of the line would be represented by whatever slope the regression results in would be equal to 2 over the acceleration, or 2 over g. And so it's pretty simple to solve that. So we had to do a little work before this. Yesterday we communicated a little bit and worked that out. So yeah, I can't give you any other suggestions right now, because I'd like to know what your uncertainty is. Does it look like you're really close to the expected value? Yes, maybe, but it's possible that you also got lucky. If you have a very large uncertainty, maybe you just got lucky there. So knowing what that fractional error is, if we have a fractional error of more than 5%, so that is to say, if you take your error divided by your value and that's more than 5%, you might want to consider how you measured time and distance. Did you just, how was that done? Let me just ask you that, and then the rest of us who are listening, this is educational for us as well, because we can get different ideas if we are looking to do our experiment for the second time or the first time. How did you measure time?
So I used a stopwatch, Professor. So when I dropped from the beginning point till it hit the ground, and it was pretty hard though. I think there's definitely been some errors there. I think next I was thinking of using the software which you have told us, the tracker, for the second experiment.
Yes. So I think that a definite way to improve on that, especially if you find that you do have a high amount of uncertainty, if you have more the high fractional error, I'm guessing you do. I'm guessing you do in that case, because if you're just eyeballing it with a stopwatch, it's really hard to have repeatable results. So that certainly would be a way to improve.
Yeah.
You might find that your z-score goes way up. Is that bad? No, not necessarily. It's just part of you improving your getting more precise measurements, right? You get points not only for being close to G, but you get points for having a high precision, that is to say, a low uncertainty. So I like where you're at. I think you have a preliminary, once we calculate that fractional error and that z-score, I think you'll know exactly what you need to do for next week.
Yeah.
Good. And then I guess, how did you, one last question that we can all think about here is, so we heard one version here where a stopwatch was used to measure that time of fall or that time of flight in the air. While I have you on the line here, how did you measure the distance or the displacement?
I used a ruler, Professor. So I kept the ruler at the back and I just dropped it. So every time
so was it
fixed.
Was it just a standard like 12-inch ruler, 30 centimeter ruler?
So first, since my thing, yes, Professor, something like that. I measured it, right,
Okay.
and I marked it, and every time I use the same spot.
Okay. Okay.
Yeah. So is that
And
fine?
so,
Like that approach?
yeah, I mean, I would have done the same thing without a camera. Uh, if, however, he had, and we can all, as we're listening into, what if he was getting a number that was significantly off from 9.81? If you had really good, if you had a really low random error, but you were still off a lot, you could be considering that maybe there was an error there. In that case, the camera version with the tracker software could help as well, because in that case, then we could hold that ruler in the screen and we could tell the computer what 1 centimeter or what 10 centimeters was and possibly get some more accurate results that way. So if you're listening out there and you're having some difficulty getting a value that's close to your expected value, it could be that measuring that distance could be a challenge. Some of you might be deciding to drop this from a greater distance out of a dorm window. I don't know what kind of experiments you guys are cooking up. I've heard some pretty cool ideas, but I'm sure there's some wild ones out there too. So I look forward to reading about all these and hearing them. But if that's the case, you could still certainly attempt that. You could film somebody dropping something out of a window with a camera somehow, but you would have to be sure to include some type of a calibration stick, so to speak, as we did. Whether that's an object of known length, does it have to be a ruler or a meter stick? No, it could be a 2x4 that you leaned against your house. As long as you measure how long the 2x4 is and then input that distance into the tracker software, it will work, right? So that's just something else to think about for all of us. So thank you for a recap there. So I hope we'll start to see some common themes here. But while I'd like as many of you as possible that are willing to, it's okay if you don't, if you're not ready. That's all right. We can still have these conversations via email or virtually throughout the week. Does anybody else want to share where they're at now, even if it's just in the design phases of your experiment, even if you don't actually have any data to share? What are you thinking? Or if you do have some numbers, you want to share them with us, that's great too.
So I don't have any numbers or anything, but I have at
That's,
least done
that's
like
okay.
or at least the first version of the experiment, and mine's a little bit similar. So I got onto the roof of my house, and I decided to drop a baseball off of it, and I had one of my parents record it from outside, and
Very good.
I had a meter stick attached to like the wall of the house. Uh, it's a little hit or it's a little offset, but so I'll have to like look at it in the recording and everything, and in the tracker software. But I'm gonna use that to figure out all my numbers and everything once I do that. So that's basically what
Okay, good.
my
So
idea is.
good. So similar design here.
Mm-hmm.
In this case, we're measuring. Instead of the previous experiment, we had a varied position or a varied displacement. You're going to go with the same position multiple times.
Yes. And
Okay.
I was going to increase the weight specifically on the second try.
Okay. Okay. So try something with some more mass.
I was thinking a bowling ball because I have
Okay.
one. So
If you have a bowling ball laying around, I actually do a similar experiment for my high school students. I get on top of the school and drop a bowling ball off into the parking lot once it's safe to do so. So yeah, I in general I like the principle here. Just a couple things to consider in terms of repeatability for the first or the second experiment. Ensuring that you're always releasing that bowling ball or baseball from the same height,
mm-hmm.
even if it varies by an inch or two. that could affect uncertainty. So that's going to bring uncertainty or randomness. I mean, it's probably pretty easy to hold a baseball to within an inch in front of your face.
That was
It might be more.
Yeah.
It might be more difficult to hold that bowling ball out there, especially when you're over the edge of the house trying not to fall off. So please don't fall off. But
yeah, of course.
But could it reduce systematic error because it's a bigger mass? Yes, it could. Could it also increase your uncertainty? Yes, it could, because it's a bigger mass and harder to hold out there in space. And then, so did you say you were using the tracker software or
Yes.
a video? Okay.
Yeah.
So yeah, I'm less worried about uncertainty with the time for you, because you're going to be able to do that even without using the tracker software. You could simply go frame by frame.
Yeah.
In your video. If you load that video into an app that has a little timestamp on the bottom, you could certainly count how many frames it is and look up the frame rate of the video in the settings. There's ways to do that even without using the tracker software, but you certainly could use the tracker software as well. Yeah, so I'm interested to see to see how that goes. Very good. Yeah, so in terms of what you change, that might be more dependent on your actual results. When you see what your fractional error is, or your z-score, you might want to change one or the other, or both. There's nothing that says you can't change both here, because we're mandating 2 experiments. So if you have errors on both ends, you might want to change both things. Good, thanks for sharing. I appreciate it. So maybe you don't feel like going outside or dropping things. The good news is this is physics, so there's lots of ways to do this. And in fact, I threw some hints to that in the lab report. Did anybody that is listening here decide, or is anybody thinking they might try the pendulum method? There is a way to simply use a mass swinging back and forth on a string to calculate G. Is anybody thinking about that? Maybe you don't know what you're thinking about yet. But,
would we do the pendulum using that formula, like T equals 2 pi square root of L over G, and then we'd calculate G based on the length and the period that we calculate?
Yes. So the equation, as I'm scribbling it out here, so yes, T equals 2 pi square root L over G here. You're not necessarily going to solve for it per se, but what I would encourage you to do is use graph time squared versus length, or length versus time squared. It really depends on how you set up your experiment, which one is the independent or the dependent variable. But I would run multiple trials, and I would graph those multiple trials and then set it up so that the slope can be found, and by obtaining that slope, you can solve for the value for G. So I'll leave the algebra to you. I can, and we can work together if you want me to double check the algebra. But essentially, yes, you would. In your case, you wouldn't even necessarily have to. You would be varying something. You would either have to consciously vary the time or consciously vary the length to certain set measured values. That would be your independent variable, and then that would be graphed on the x-axis. Typically with pendulums, as we did in our experiment, you change the length, and so the length would end up being on the x-axis, and then probably time squared, or time, depending on how you do it, would be on the y-axis, since it's the dependent variable. So setting it up so that it's in slope-intercept form and solving for G. Yeah, I like that approach. If I mean, I have a 2-story house with a walkout basement, so if I was doing this, I would probably drop stuff off out the back of my house. But if I lived in a smaller apartment or had a one-story house where I couldn't drop stuff at a great distance, I would really strongly consider doing this pendulum approach, where you don't need to drop things out the window. Have you thought about how you're going to measure time in this experiment yet?
Oh, I was just, you brought up the idea of doing the pendulum, and I was just kind of brainstorming.
Yeah.
So I'm not really sure if I'm going to do the pendulum or the dropping approach.
Okay.
But I was just, since you brought it up, I think I had loosely thought about it after you made the hint last week. So
sure. Again, a stopwatch method is perfectly fine if that's all you have, but we all have phones, so it would be, as we were talking about it with a couple of the other students, it would be reasonably easy to take a video with your phone of that and go frame by frame and count how many frames it takes to make one period. And that could even, if you have the tracker software downloaded, even if all you use the tracker software is to find the delta t, the change, how long it takes to repeat one cycle of the pendulum. If that's all you use the tracker software for, great. Then it more than paid for itself, and it's free anyway. So those are just two different approaches that you could use to do that. Don't forget about if any of you are considering this pendulum approach, measuring the length of the pendulum. We talked about this way back in January, but remembering that the length of a pendulum is measured from the pivot point to the center of mass, whatever that is. And so it's not just the length of the string. You would have to have some way to measure the diameter or radius of a ball or a mass. Hopefully you could find something symmetrical, a ball that you could tie to a string, something along those lines. But yeah, that's definitely a whole other different approach that you could take to this experiment. So great, yeah, thanks for throwing that idea out there. I think I'm expecting we'll have one or two people probably try the pendulum approach here, just based on the limitations of where you're living or what you have access to, certainly.
Also just curious, I kind of thought about this, and this is probably a bad idea, but would it be possible to calculate it with rolling like a ball down a ramp, and like the angle, and you'd like expect how much the angle would like reduce the acceleration of the ball?
Yeah, that's actually a great idea. That's not an equation I can throw out in my head here. It takes a little bit of deriving, but it's actually not that challenging. There's certainly all kinds of physics problems that are worked out on YouTube and online, and probably ones you've done in your notes in the book that have you do exactly that, where G is part of that equation. So that brainstorming activity I had you guys do, where you just were supposed to flip through your notes and look through ideas, it's possible you would have come across a problem like that in your notes from the lecture or from a homework assignment or something like that. Absolutely. Rolling something down a ramp, measuring the angle, which we can do with an app on our phone, measuring the time that it takes to go or the length of the ramp. So there's actually multiple different ways as I'm brainstorming that you could measure those values and solve for G. The general theme, though, for all these is the same. We would want to take some multiple number of measurements by changing something and then graphing them. So the other approach would be Sam's approach, is where we're measuring the same thing multiple times. So he's not going to be using necessarily a linear regression approach, but he'd be using still an average and a standard deviation approach to calculate his calculated value and his uncertainty. Again, uncertainty and standard deviation mean the same thing for us. So again, we've thrown around a lot of ideas here. Feel free to mix and match. Maybe you have your own idea, so I'll stop talking for a little longer. I can stay on here as long as you guys need me to. But does anybody else want to share any possible ideas, things that you've brainstormed about, or maybe even any experiments you've done or thought about doing? Well, I'll take that silence as a no, unless anybody wants to speak up now. I had a couple questions about the midterm / final that we never took. I mean, as you know, the midterm would have been that week that we came back after spring break that we never ended up coming back to. At this point, the midterm that I would have given back then is not happening, so I can say that much. I am considering some type of a brief final assessment. It would be in the format of multiple choice. It would be in the format of a Blackboard type quiz. It would be all open book, open notes, open lab. And it would not be something that is very long. And it might not even happen. I was just asked this question by a few students this afternoon, and I honestly hadn't really thought about it. I was kind of busy preparing for this last lab and working on some other things, getting caught up on grading. So I'm going to make a decision on that tonight, and I'll let you know in the next 24 hours where we're going with that. Because that is really that's the one aspect of the class that we haven't really had is any kind of a formal standardized exam. Not that I feel that we need one, because this is a lab class. There's part of me that says this class is evaluating you on the lab aspect, which you guys. That's what we're displaying. That's what you're demonstrating by doing these labs in the first place. So do we really need a formal assessment? If you ask me that question, no, I don't feel that it's a definite need. It's just a part of the class that we typically have, but we have not yet had. So that's just, I need to make that professional decision. I will do so and communicate with that with you via email, but it's something that I have been thinking about. So just kind of the end of the semester sneaks up on you after you're kind of rewriting the class as we go along here, as I'm sure many of you have. It's just been a struggle to keep your bearings straight with a whole different direction that you've had to go in many of your classes. Last chance. Anybody want to share any final thoughts or ideas before we all head our own respective ways? So I will be monitoring my email box and messages throughout the week. If you personally and I need to have a quick Google Meet session like this, sometimes it's faster just to have a quick 5-minute conversation to run your ideas past me, as the 3 students today already have. They've fulfilled their obligations for consulting with the professor. So the rest of you will still need to do so in some form or fashion via a message, a quick chat, just like we're having here, an email, something along those lines. But definitely have some fun with this, and I'll also try to improve on that second trial. Whatever you do, even if it crashes and burns, as long as you write about what your thoughts were and document what happened, it's good. Okay, this is a learning process. We don't expect you to be accurate to within 10 thousandths of the 10,000th place of G on your first trial. We certainly don't. But what we do expect is to document what you've done properly in all the ways that you have learned how throughout the semester. And I just want to take the last minute here, since this is the last time we're all meeting as a class, just to say thank you to you all. Best wishes to you all. I've been floored by your hard work and your really good, really thoughtful, really challenging questions that I've had to try to answer via email. It's been hard for a lot of reasons, but you guys have kept the learning going. So I just want to congratulate you guys for keeping that learning process going through really difficult times, through really difficult circumstances that really nobody ever could have planned for. You guys did fantastic. So if there's anything I can do in the last couple of weeks of the class to help, whether that means some corrections from a lab a couple of weeks ago that you never got around to, whether that's just a last-minute conversation about this lab, please just let me know what I can do to help. It's my sincere goal not to have you regret anything about this class. I certainly hope you're not angry at the class or how it was run or how it went. So if you are, if there's anything that I've done or not done as part of this whole e-learning process, please let me know so I can try to make it right the best that I can. So Thanks again to you all. If I don't speak to you live, best wishes to you. Have a great summer, and best wishes for your future. Bye, everybody.
Thank you, Professor.
Thank you.
Professor.
Just a brief question. Is there like a time that works best for you to do a meet or something? Like when I have like a more like